I come from, well, first of all, I'm a program manager here at Microsoft in the Visual Studio Ultimate team. And I come from an academic research background. And some of the work you'll see here today was my graduate work. And then other work was done here at Microsoft in collaboration with a number of different groups and many people involved, including Microsoft Research. So we'll kind of see a couple different things today. But first, I'd kind of like to start with the problem. As you no doubt know, features today are often spread throughout code in the form of a cross-cutting concern and are represented in many different methods. But creating side-by-side views of all these methods so you can see them all at once is very, very difficult. It's possible, but it's very difficult. And as a result, developers can't really see all the relevant code at once. What they have to do is kind of navigate from one point to another repeatedly to see each piece of code one at a time, but they can never see it all at once. So for example, here you can see a developer using Eclipse with their tab pane design, trying to resize these tab panes and scroll them and size and place them so that they can see just 4 methods at once. And as you can see, it's very tedious because when you move one, it adjusts the next one and so on. Another approach that has been tried in the past, here you can see Visual Studio in MDI mode, which has different problems. Here the user has to manage Z order, what's in front of what is the exact size and position of everything. So creating these side-by-side views of code can be quite difficult. And developers spend a significant amount of their time reading and navigating code. One study pegs that number as high as 60 to 90%. And for complex visual comparison tasks, from the visualization literature, we know that it's better to use multiple side-by-side views. It's more efficient to do that than to kind of navigate back and forth. And so if that's true for visualization, and because developers navigate and read so frequently, and because code is so complex, it's our core research hypothesis that multiple concurrent views could be very beneficial for developer productivity. In particular, working sets of fragments might allow developers to inspect and compare methods, identify commonalities, parallels, and differences, navigate through complex, unfamiliar code without fear of getting lost, support interruption recovery, and possibly even offload limited human working memory. So before I get into some of the design, I just want to outline some of the challenges. As you know, file-based views are very large by default and require many interaction steps to concisely display a single method. In addition, code has a lot of white space in it. It's got long lines, it has blank lines, and this consumes a lot of space. So it's actually, even if you could lay it out easily, they might take up so much space that you wouldn't be able to see very much. In addition, once you've laid out some code in multiple views, when you want to add another view, it's a lot of work. You have to modify the window pane layout, and it takes usually multiple interaction steps, which are very tedious. Finally, even if you could solve all of these problems, the size of the display is ultimately kind of an upper limit. How many methods are you really going to be able to see at once, given that your display is basically a fixed rectangle? So this is our approach, code bubbles. Here you can see the user right-clicks and does an in situ search and opens a method that's relevant. And then when they perform an open declaration operation, rather than navigating from one point to another, that other method is opened side by side in a concurrent view of code. And each method is its own unit, its own bubble that can be moved and manipulated independently. And they group together to form related clusters automatically. And you can close things that are not relevant, and you can move those groups by grabbing on the group boundary. Also, for operations that logically return multiple things rather than a single thing, we have bubble stacks. For example, find all references in this case. The user can tear out methods of interest and keep them around in their working set. So that's just kind of a quick overview. Some of our research goals are that a developer should be able to get one of these concurrent views of code for free. They shouldn't have to do any significant extra work, any significant extra interactions than they would normally have to do. In addition, it really needs to scale. If it doesn't support large working sets, then it's probably not going to be of any use. And we really need to automate all of those tedious manipulations I mentioned earlier. We really need to do those obvious operations for you and not waste your time. So we start with saving space. one simple thing that we do is we do syntax-aware reflow. So we analyze the syntax, and we find syntactically appropriate points to wrap the code. In this case, plus signs. And you can see that when we wrap the code, we indent it, and we kind of do it the way a programmer would. And you can save quite a bit of space by doing that. You could fit a lot more code within the same area of the display. For vertical methods, for methods that are very tall, what we do is we collapse basic blocks. If statements, while statements, and we leave behind the if or while statement as kind of a summary of what's inside the block. And the user can, of course, expand it, but it starts them out with something much smaller, much more manageable. Here you can see a quick video of the user resizing a method. All of the reflow that I mentioned happens in the view, and so when they do this, it doesn't modify the underlying file. It just happens in the view. We also try to minimize Chrome. On the left-hand side, you can see MDI tool window or MDI child window in Visual Studio. It's got a lot of visual noise, has a lot of widgets, a lot of kind of harsh lines that could be distracting. So for code bubbles, really what we sought to do was eliminate as much of that visual noise as possible and just show just the code and the bare minimum beyond that. Some context, no title bar, no widgets. And we do, though, provide a breadcrumb bar which shows the class and namespaces, and you can click on that to drop down and get some context from the class. You can open other methods from there. You can hover over them to get some context, but primarily it displays a method. So to create bubbles, we have the in situ search box, which I showed before. It does simple Boolean substring matching, kind of like control comma, and it just opens the bubble up in place. Once you've got multiple bubbles, we provide grouping to help you manage them. So here you can see a video of someone dragging bubbles, and when they come in contact with each other, they automatically join together to form groups, and then you can use that affordance to move that group of bubbles around. Whoops. Another visual affordance that we provide is connections. So when you perform those open declaration or find all references operations, we show a connection between the two bubbles to illustrate the relationship. And we also do a little bit of lightweight connection routing to eliminate overlap, make it easier to trace back. And in fact, we also show recursive highlighting of the incoming relationships to a given bubble. We also have bubble stacks. Here you can see the user performs a find all references operation on one variable, and then another find all references operation on another variable. And they can actually, because it's not a tool window, they can have as many instances of this as they want. So they can chain together and explore the relationships up rather than down, as I showed earlier. And they can also tear things out and make them a permanent part of the workspace if it's relevant to their task. Let's see. So to help users manage working sets, we really don't want users to have to do a lot of that kind of tedious manual manipulation I referred to earlier. Really, if a user wants to move, say, a bubble from point A to point B, their goal is just to move it from point A to point B. It's not move it from point A to point B and then move the three things that are now overlapping it out of the way. So what we do is we have a simple, automatic, incremental layout assistance algorithm. This is not auto-arrange, so it tries to minimize the total amount of changes, and it uses a look-ahead algorithm. So here you can see when the user drags the bubbles around, any overlapping bubbles will be pushed out of the way, but it tries to find a global minimum, and so it minimizes the total amount of movement and it maintains adjacency relationships. You can see that same algorithm is used when you add more code to a bubble. The bubble gets taller, the bubble below is pushed out of the way. And we find this pretty natural because already in a text editor, when you hit carriage return, all the code below the cursor will slide down. So it's really just like that. It doesn't end up being distracting. You can also type new methods. If you do that, they'll bud and split off into a separate method, and then at that point, they'll become their own bubble that you can move and manipulate independently of the others. Let's see. We also provide a continuous 2D workspace, so it's not discrete like many of the window managers you may have used. When you run out of space, rather than switching to a whole other world, you can just incrementally pan over and add a little bit more space that you actually need. So here you can see the users using the Package Explorer to open some methods, and they can just kind of work from left to right. If they need more space, they can just incrementally pan over and add more space and just open additional relevant content in the space that becomes available. If you leave something behind, you can use the transient zoom feature, which will zoom you out, and you can grab groups or bubbles that have been left behind and then bring them into the current view without having to kind of pan and clutch over to get them. And once you bring them in, they'll behave just as you might expect. You can add any relevant content into your working set. Is there a question?
Can you assign color? Let's say you've got a layered architecture, you want to put color in the business so that you can quickly associate that code with that layer.
You can change the color of the groups, and we did also experiment a little bit with being able to change the color of the individual bubbles as well.
How about like within a project? I may have a project that's the database side. So anything in the database is on that.
So the question was, can you assign, say, a particular project or solution to have a particular color? It's a great idea. That isn't something specifically we've explored, but it would definitely be something that would be very interesting to look at. I'm just going to try to get this video to play again. Let's see if that will work. So the other thing you can do with transient zooming is you can hit a key and it will automatically zoom out, and then there will be a key overlay on all the bubbles, and then you just press the corresponding key and you'll automatically be zoomed in on that bubble. So it's kind of a keyboard way of getting around potentially large workspace. Yes?
Is there a logical way that the keys are set out so I don't actually have to find the bubble and hit that key?
It's a great question. So the keys currently are non-mnemonic. So they're assigned in a random way. And what we think is you basically look at the one you want, and then when you zoom out, you can see the key appear, and then you kind of hit the matching key. It's a great question. So the question is, can you use tabs to get around? We do have a different method for that. You can hold down a key and then use the arrow keys to kind of shift focus up, down, left, right. There's also a non-zooming version of the key overlay. But one question you might have at this point is, okay, this is interesting, but does it really make developers more productive? So at this point what we did was we did a couple of experiments, one of which I'll show here. And the goal really was to have participants come in and read and understand unfamiliar code with a well-defined goal. And so what we did was we gave them a project they hadn't seen before, and we asked them to fix a bug without using the debugger. The bug more involved a logic error, so it's the kind of thing you could spot by reading the code. And so what we did was we recruited 20 graduate and third and fourth year undergraduate students from Brown Computer Science. It's notable that Eclipse is used in most of the Brown courses, and students or participants self-reported an average of about 3.8 years experience with Eclipse and self-rated average or higher in Java expertise. And we used a between subjects design. So what that means is we divided the participants into two groups. One group got Eclipse 3.4, full default install, full access to keyboard shortcuts and all the features available in Eclipse Standard Edition. And then the other group got code bubbles. We disabled some features. We disabled the pop-up search box, groups, and zooming because Eclipse doesn't have a direct analog to those, and we wanted to kind of minimize the number of independent variables. And we gave them a 24-inch monitor with a 1920 by 1200 resolution, which is reasonably typical monitor. And then we had a hardware video capture of everything they did. So for the task, we gave them a vector-based drawing program, a simple program called ShapeDraw, which had about 2,700 lines of code. And after an initial training intro task, we gave them two 45-minute tasks. One to read and understand the code related to undo and redo, and the other in the graph drawing code. And each one of these feature areas involved 30 to 40 potentially relevant functions. And we gave all the participants a common starting point, which was just the toolbar event handler for, you can see the toolbar here on the left. So there were about 280 methods total, and the overall statistics roughly match some open source projects. It's notable, though, that we wrapped all of the non-trivial APIs because we didn't want there to be a prior knowledge bias for some people who are more experienced with, say, client applications than web applications or the particular APIs that were used. And that was another reason why we didn't use open source. So we really wrapped everything so everyone was on an even footing of not knowing the APIs. So for the results, for task 1, code bubbles users performed statistically significantly faster. For task 2, there was a difference in the mean, but it wasn't significant. And then for the total completion time, code bubbles users were 33% faster, and that was statistically significant. We hypothesized that for the second task, which was not significant, that the time limit effectively had a ceiling effect, kind of lowering the overall time for the eclipse control because they were basically running out of time. For task completion, task 1 was completed significantly more often with code bubbles. Again, was not significant for task 2. You can see in the graph on the right the difference. And then the overall number of tasks completed was significant as well. In terms of navigations, we had an independent set of screen coders analyze all of the screen recordings down to the frame level. And we found that code bubbles users performed significantly fewer navigations per minute for both tasks. You can see in the graph on the left. And they also performed significantly fewer repeat navigations for both tasks. In fact, for Eclipse, you can see that over 75% of all the navigations they did were back to a method they had already seen at least once. So there was a lot of wasted navigation there. And you can see that it dropped quite a bit with the code bubbles users. Code bubbles users also spent significantly less time navigating and spent a significantly smaller percentage of their total time navigating. It's notable, though, that the controlled nature of the study places obvious limitations on the generality of results, and that we expect there will be tasks which won't show improvement. For example, if a user needs to read and edit a single method in isolation, you probably wouldn't expect that to show performance improvement, or if they're reading and editing methods in a purely sequential fashion, you probably would not expect to see benefit there either. However, these tasks would probably perform comparably. Overall, though, we believe that the results do support the core hypothesis that programmers can understand code faster and with less effort for the two controlled tasks. And we note the significantly improved completion time, reduced navigations per minute, navigation time, and repeat navigations. One thing that was surprising, though, was that the improvement, the reduction in navigation time spent only accounts for about a third of the total performance gain. And we hypothesize that this means that the remaining two-thirds of the performance gain actually came from offloading the limited working memory of the developers onto the screen. They didn't have to remember exactly where they had come from, and so that freed up their human working memory to think more about their task. And so we hypothesize that this may account for the remaining cognitive benefit. We also noted that participants on average had 11 concurrently visible methods on the screen, and they had 17 total. So they had a few more visible on screen than would fit. We also observed that they took advantage of spatial arrangements. For example, in the undo and redo task, they arranged all the functions relating to undo in one arrangement. That was a common pattern. And then they would arrange all the redo functions in another arrangement so that they could kind of compare across. So now I'd like to talk a little bit about how you can extend some of these ideas beyond just reading and navigating code to kind of the IDE as a whole. So one of the first things we looked at was just adding more types of content into the workspace. So here the user starts out by opening a task or work item, and then that can kind of form the core of their exploration, and they can refer back to that as they open additional code or other content. So here they can just perform some exploration of the code relating to the bug, and they can also bring up documentation using the same search box. So they can just open relevant documentation, explore and read that. The same types of navigation operations that you can do with the code, you can also do with the navigation. So you can browse laterally that way as well if you need to compare a couple of documentation classes, for example. You can also open a particular method in the documentation if there's something you're planning on using and want to have that kind of available for reference. We also explored a couple other types of bubbles. You can create visual flags, which are kind of like landmarks within the space to help you find your way back to where you were. And you can also create note bubbles, which are sort of like sticky notes. You can write notes to yourself or to-dos. And these annotations are always available, so you can kind of always take advantage of them if you need them. Some other types of content that we looked at is other types of code besides functions. You can you can collect all the member variables from a class into one bubble. You can open a top of class bubble, which kind of just shows your using and import statements at the top, class declaration. You can open the full class in a bubble if you want. Usually it creates a pretty large one. So what we do is collapse all the methods by default. You can expand them or tear them out if you want, though. We also explored autocomplete. So you can make a method call in the autocomplete, and if that method doesn't already exist, you can choose the first option there, which is create new method. What that does is create a stub method in whatever the actual class would be. And then when you do that, that stub method will be opened off to the side in a new bubble, and you can just continue on and finish any coding that you were doing in the original method you started in, and then you can take advantage of the stub methods off to the side. If you say, decide you want to add a parameter to that function, it's really easy because both the place where you're calling it and the place where it's defined are both together right there on the display. We also looked at call path analysis. You can open a couple of potentially interesting methods, and you might wonder, does this one ever call that one? You can perform a gesture where you draw a line with the mouse, and the back end will perform a static call graph analysis, which will open will find the shortest path between the two methods if it exists, and then it also shows a little overlay indicating other possible branching paths from that point besides the shortest path. We also looked at groups. You can persist the group information after you form a group. So, for example, you can then search for groups by the name or contents of the group and then reopen it later. And you can also use that to discover related functions. For example, if there's no specific structure that one method calls another, either directly or indirectly, they may still be related. So, for example, in this case, the user opens a method of interest, and then once they do that, they can perform a query that says, what groups is this method a member of? And you could potentially discover other methods that are semantically related, but that are not actually called in a direct chain. We also looked at multitasking and interruption recovery. We really, based on prior research, we know that developers can be interrupted very frequently, perhaps as often as every 3 minutes. And we also know that the tasks and the multitasking can really range in the time scale. It could be very short to all the way up to weeks or months. And so we really wanted to support both of those scenarios, the kind of rapid multitasking, interruptions, and also the kind of longer-term working on a task. So here you can see the user's interrupted. So what they do is they just click on an unused portion of the workspace, which is empty. They can open content relevant to this new interruption task. They can do that task, whatever it may be, if it's an investigation or writing some code, whatever it is, the high priority task. When they're done, they can simply click back to where they were, and all of their content is still there. And the spatial relationships and any annotations that they've made and the connections between the bubbles and all this rich context is available to help you kind of remind you what you were doing and resume that interruption faster. You can also, along those lines, you can define tasks within the workspace. So here what the user is going to do is create a note bubble, and then they can define this region of the panning bar as having a particular task, and it will have exactly this scope. And then you can actually send that as an email message. And you can either send it as an XML attachment or other options, and then the recipient can import that into their workspace to get the same view. To help users multitask over the longer term, we looked at the notion of the task shelf. So once you've defined a task, you can close it. And when you close it, it doesn't delete it. What it does is it sticks it into the task shelf. And then you can go back into the task shelf at any time and just import old tasks that you had been working on in the past. And all of the context associated with those tasks will come back. And you can just pan through and kind of regain some of that context of what you've been working on before. Another thing that you can do is sharing. Oh, yeah, question?
How the source code files hand up by each bubble has different source code files?
So the question is, does each bubble have its own source code file? In general, each bubble represents just a method, so it's a subset. a file in most cases, based on the syntax. So you can also export it as a PDF, which is something in our qualitative user studies developers are really excited about, because you can kind of make a visual explanation of a problem, or you can document a canonical case of, say, how to do something. And then you can save that as a PDF file, put it on SharePoint for reference, or you can email it, or you can attach it to a bug in a work item tracking system. And then that can become part of the life cycle of the code. But creating that diagram is very cheap, because it's just saving what you've already done. Did you have a question?
Yeah. For the model where you were trying to give, I think it was the taskbar, task shelf for longer term interruptions. If you were working on some code and you left it for a week and came back to it, if that code was looking at source files that had since been updated, does that code all get re-updated?
It's a great question. So the question is, how does this integrate with source control? So if you go back to an old task, what version is it going to be on? What happens if the code has been deleted or something? I think the ideal way that it would work is it would leverage the new My Work feature that we have in the next version of Visual Studio, not to plug it too much, but when you suspend a task in Visual Studio Next, it will actually keep all of that state exactly where you were. So when you resume the task, it will bring you back to that state. And so, so what I would say is the ideal design would be to do that. For our research prototype, it's more of a view on the code. So you end up in Bug City pretty much. You can also print these things out, hang them up on the wall if you want to have an architecture discussion. We also looked at breakpoint debugging. So here you can see the user is going to just open up a method of interest, and there's a breakpoint gutter bar just like there is in Visual Studio. And when you click there, you'll get your typical breakpoint, except in the context of a method. Then now when the user runs the code, instead of ending up in a file with a current line, they end up in just the bubble. And there is a call stack bubble that shows the incoming calls. Then when the user steps into the code, instead of navigating, the code opens to the side, and you can see all of the methods at the same time. And you can actually inspect values in variables, and those variable values will be loaded into a data structure bubble. Now notice when the user steps out, those bubbles don't get closed, they stay open. So now if you step into a different call hierarchy branch, you can inspect values there, and now the old values are still available for comparison and reference. In this case, annotation. The user notices that that's actually the source of their problem. No more having to write things down on a piece of paper or use your working memory to store that or anything like that. The other thing that's of interest here is that when you click stop, we don't clear the screen. What we do is we keep all of your context there, and you can use that in the future. For example, let's say the user has identified this issue. Now they go fix the problem, or they think they fixed the problem. Now it's time to run again. When they run, what we do is we split the screen and we show the new running session side by side with the old one. And now when you step through the code and inspect values in this new instance of the application, you have all of this historical debugging information available. You can make comparisons across the hierarchy in your current running instance, or compare between the current running instance and the previous running instance. Also, if you hit another breakpoint, like the program is kind of run for a while and hit another breakpoint, that will also open. And essentially, it's a historical view on all the data that you've sort of carefully collected. It doesn't automatically destroy data the way debuggers have kind of a tendency to do today. You can also direct trace statements and printouts to different named call stack bubbles, different console bubbles, and you can just integrate these into your view as appropriate. If you have a cluster of stuff that is your back end and a separate cluster that is your front end, you can incorporate those trace statements as appropriate. The other thing I'd point out about the debugging is that we have this channels experience where each one of the debugging channels is independently pannable, and so can accommodate a very large or very long debugging history session. And it's really more of a window into that continuous space. So you can actually, even though it looks like half the screen, you can scale up. And you can certainly maximize and just show one channel if you're not interested in history. So now what I'd like to do is show a quick demo of a tool called Debugger Canvas, which is a power tool we've released and you can actually download today for Visual Studio, which implements some of these ideas in Visual Studio with the full Visual Studio editor. It was done in collaboration with Microsoft Research, among others. And there's a new version which is about to be released. There's an older version that's been out for a couple months now, and we have a refresh that'll be coming out very soon. So what I'm going to demo is that new version. So what I have here is Visual Studio 10, and I've got a Paint program open. I don't know if you can see that okay. So what I'm going to do is, I've never seen this program before, and I want to understand just kind of what does it do. And I'm not sure where to set a breakpoint because, again, I've never worked with this code before. So what I'm going to do is I'm going to just run the program. And you notice I have the IntelliTrace window here. What I'm going to do is I'm just going to scribble in the Paint program, and then I'm going to click Break All in IntelliTrace. And what I can do is I can actually go to Debugger Canvas and create a new canvas, and I can simply drag the calls onto the canvas. And what that's going to do is populate all of the methods that were called and all of the context from IntelliTrace into my workspace. And you can see here if I just max. Oops, something funny about the video is cropping here for me, but I can zoom out so you can see a little better, and you can actually pan around using the panning bar up here at the top. And so let's say let me just zoom back in again, and let's say I'm interested in a particular variable or particular string. What I can do is I can actually just take advantage of typical Visual Studio features that I would expect to work, like find. So if I just do a find, I can actually just search through this space of code, and I get a smooth animation around in the workspace, as I navigate through. So that's one thing you can do with Debugger Canvas is visualize IntelliTrace logs, which can be particularly useful for ASP.NET applications. You can also use it to do more traditional debugging. So if I open this method of interest and I just click here and set a breakpoint, run the application, and I just click. You can see at this point, I've hit the breakpoint and I'm in my traditional file editor. So I didn't have to decide a priori that I wanted to use Debugger Canvas. I'm in my file editor. Maybe it's frustrating, so what I do is I just click this button that will take me over to Debugger Canvas. You can switch like that anytime you want between the two debuggers, just by clicking this button. And then at this point, I can actually just step through the code as I normally would, and then just in the demo, like in the previous demo as I showed you, when you step through, you continue to step into the hierarchy. And now that I've got 3 methods open, you can open the full Visual Studio locals data available for each of these methods, and if you like, you can actually pin these, and they'll become their own bubbles, which can be moved and manipulated as well. So, let's say that I'm interested in comparing these sets of values. I can actually just place them side by side for comparison. Let's say I need a little more context. I can actually navigate up the stack. So if I click these buttons, I can navigate up the call hierarchy until I get to a method that I haven't opened yet. You can kind of incrementally drive up the call stack if that's what you want to do. Let's say at this point I've identified the issue, though, and I'm pretty sure what it is. So what I can do is I can add a sticky note, and a little bit of a bug there. I can say, this seems to be the issue. And now that I've kind of set up this context, maybe this isn't my code, what I can do is right-click, and I can attach it as an XPS file to a new email message. So what this is going to do is launch Outlook, and you can see there's a 146 kilobyte XPS file attached here. And this is a full, vector representation. So I can pan around, I can zoom in if I want to, and all of the code is selectable. And you can share this with someone. Again, you can attach it to a work item as documentation or as any additional material that you need to, and you can just send that off via email. Files generally stay pretty small because it's just XML. So let's see. One thing I can show you real quick as well is if I stop the debugger and I pan over here, this is the full Visual Studio editor. So I have IntelliSense, I can say like console.writeLine and, hello. And I can just type right in here if I'm comfortable doing that. Or I can right click and I can say navigate to file. And what that'll do is actually open the file editor and place my cursor in exactly the same place and scroll it into view. You can actually just click back if you want to. The other thing that's notable here is it's fully synchronized in real time. So if I type some stuff here like this comment, then I flip back over to this tab, you can see it just shows up there. And they're all synchronized in real time. So another thing I'll do is you can also use this to just write code or read code if you want. So if I create a new canvas, I can just right click and I have the Institute search box. So if I want to open, say, this method, and I want to open set paint object type, and I want to open set thickness, and if this is my code and I know what methods I want, I can just very quickly open a set of relevant methods, and I can just see them all together. Another thing you can do is you can take advantage of this breadcrumb bar to access other methods in the class. This, by the way, works for Visual Basic and C#. You can just access other methods that are of interest to you. Another thing that you can do is that because this is the full editor, you can just drag and drop. So, for example, if I just drag this code over here, I can just, and undo will work. Oops, maybe not. There's still some bugs to be worked out there. You can also, because we don't have grouping, as you may have noticed, you can multi-select bubbles. You can actually drag them around as a group like that. So let me just flip back over to PowerPoint. So that's just that is a very quick demo of Debugger Canvas, which is downloadable today. You can use this URL, or you can just search your favorite search engine for Debugger Canvas, probably easier. It does require Visual Studio Ultimate. However, it will work with a free trial of Ultimate. The reason it requires Ultimate is that there are some visualization back-end features in Ultimate that support cross-language abstract syntax trees, which are needed to make a lot of this stuff work, and that's how this is able to support Visual Basic and C#. This will also be available in the hands-on lab sessions on Friday, so you can actually try it out there as well. So to take things in a little different direction, this is a little more out there. This is a project we did in Microsoft Research to look at supporting co-located developer meetings where everyone has access to a smartphone or a tablet, and there could be a large touch wall in the conference room with pen and touch input, and you can have several Kinect type devices to do people tracking. So what I'd like to do is just play this video for you. We present CodeSpace, combining touch, devices, and skeletal tracking to support developer meetings. CodeSpace enables cross-device interactions, or multimodal input techniques that combine in-ear pointing and postures, physical proximity, direct touch input, and motion sensing input channels together into a single interaction. CodeSpace builds on the code bubbles visualization metaphor, in which individual methods, bug reports, sticky notes, and diagrams are displayed in individual bubbles that can be moved and manipulated with touch. Users can pinch to zoom the workspace or an individual bubble. Touch dragging on the background pans a virtual workspace, while touch dragging on a bubble moves that individual bubble. Users can also write on top of the bubbles using digital ink, much like they would on a traditional whiteboard. Our goal is to allow developers to easily bring digital artifacts into a whiteboarding experience and then annotate them as needed. Users are free to ink in the space between bubbles to indicate relationships, or over individual bubbles to highlight specific features. Many development meetings focus on categorizing or prioritizing a set of items, such as bugs. Workflow templates allow developers to add the lightweight structure of visual buckets to aid in categorizing items. Multiple template configurations are available, and since they are not tied to specific tasks, Users can appropriate them as needed. When an audience member points at the display, skeletal tracking identifies the gesture and displays a cursor on the shared display, allowing them to point out precise locations to the group. Audience members can also manipulate objects by forming a flat palm posture with their hand, switching the system into drag mode. Objects under the cursor will now be dragged with the user's hand motion until released. Audience members can also use a mobile phone to interact with the shared display. Users may point the phone at the display much like a remote control, showing a cursor. To drag items, instead of changing hand posture, users can touch down on the phone to drag. We explored phone manipulation as an alternative to hand posture manipulation for users who brought a smartphone with them. To augment pointing, the user can also add temporary ink using their phone. By pressing and holding an ink icon on the phone while pointing in the air, they can highlight regions of interest. Because the ink is of low precision, we clear it on release. Users can execute commands from the audience by pointing the phone at the display and gesturing. In this case, the user performs flick gestures to pan the display to access content that is off the screen. Users can also pull content down onto their phones to view or edit locally. The user points the phone at an object they would like to pull, and then flicks down to pull the object onto the phone. Once the object has been transferred, the user can resize and manipulate it locally. In this case, it is a bug, and so the user chooses to edit its priority and status. The saved changes will be reflected on both the phone and shared display. Users can perform the reverse gesture to push content to the shared display. Users felt that presenters should be given the ability to preview content before accepting it into their presentation. To support this, content sent to the shared display will initially appear as a package. The presenter can then hover over the package for a preview and then tap to open it. Users may want to briefly show an object to the group, the equivalent of holding up a piece of paper to share. By combining the phone's accelerometers with skeletal tracking, users can hold up the phone to transiently share for as long as the phone is held up. The presenter can tear off the shared content to make it a permanent part of the display, otherwise it will be dismissed when the user puts their phone down. Users can also transfer content to a touch-enabled laptop. Pointing at the shared display specifies what to transfer and also puts the laptop into gesture mode as indicated by a screen overlay, which also shows the available gestures. The user can then swipe down on the location they would like to place an object. Working locally, the user takes advantage of the keyboard. The user then performs a reverse gesture to share their work with the group. In this case, no presenter is present at the display, so the package opens implicitly. Users can also take advantage of people tracking by pointing a phone at another user and then flicking up to share with them. We also provide users with a passive tertiary display that extends above the region comfortably reachable with direct touch. Users can then send content to the tertiary display from the shared display by pointing at it and then flicking up on the objects to send. Because users can pan and zoom the shared display, this creates the potential for contention issues with two or more presenters. We automatically split the display in place when multiple presenters are present to give each user a separate view of the same underlying content. Toolbars can be ineffective on large displays as they may require users to walk to reach distant commands. We explore posture-invoked tool palettes. To open a posture palette in situ, the user simply forms an open palm posture in front of the display. The palette will track the position of the user's hand and is dismissed when they stop forming the posture. Another advantage of using the hover state is that users do not need to touch the screen to open the palette, which helps to minimize the chance of accidentally selecting objects. Users can also use posture to enter gesture mode on the shared display. We use the same posture to minimize approachability issues. Users can gesture freely on the canvas while the posture is open to invoke commands. The set of mark-based commands is disclosed using a marking menu when the user dwells at the beginning of an input stroke. Here we see the user step through code using the debugger with gestures. We also include a scribble gesture which the user can use to erase the display. We have presented CodeSpace, a system for supporting co-located small group developer meetings by democratizing access, control, and sharing of information across multiple devices and shared displays. Okay, so in conclusion, I've shown you some different things today. We talked about the code bubbles metaphor and how you can use that to read and navigate code. And I presented a quick sample of some quantitative evaluation work that we did to determine to what extent it improves performance for several control tasks. And I also described some extensions to kind of extend it to more IDE tasks beyond just reading and navigating code. I also showed you a quick demo of Debugger Canvas, which I'll remind you can download for free. It's available on the DevLabs site, and you can just Google that. Or Bing, sorry. And then I also demoed something a little more out there, CodeSpace, which is more of a research prototype to explore some new interaction techniques around developer co-located meetings. So thank you very much for your attention. I'd be happy to take any questions.